Hello everyone, I'm Feny. I'm based out of Bangalore, India. I have been working with Red Hat since past 3 years. And at work, I mostly spend my time developing and maintaining open source Kubernetes controllers. With this, I'll hand over the baton to Francesco.
Hi everyone, I'm Francesco, I'm from Italy, and I joined Red Hat 2 years ago. I usually spend most of my time developing Kubernetes controller and contributing to the open source world the best that I can. Today, I'll be playing the role of the developer and of the mentee, whereas Feny will be the architect and my mentor. So I'll give it back to Feny to start the talk.
Okay. In the past few years, we have worked on several Kubernetes controllers, and as any newcomer, we have made a lot of mistakes and we tried to learn from them. Today, as the talk title says, we would like to focus on controller design and good practices. We'll introduce the main concepts around extending Kubernetes and then move on to some demos. While working on controllers, we may implement different designs and we will highlight the pros and cons of those designs. But before going deeper into the talk, let's do a little survey. Please raise your hand if you have already implemented a Kubernetes controller. Okay, quite a few. How many of you have implemented a controller with 3 CRDs? At least? Okay. Maybe more than 5? Okay. We have quite a few people who are already familiar with the concepts, but I'll still try to brush up some of the key concepts so that it's easier for us to dive into the demos. When we talk about extending Kubernetes, we can't avoid speaking about custom resources and controllers. CRs are a very important part of the Kubernetes stack. They allow us to extend Kubernetes functionalities by adding our own concepts to it. Indeed, a custom resource is an extension of the Kubernetes API that is not necessarily available in a default Kubernetes installation. They have become so important that even many core Kubernetes functions are now built using custom resources, making Kubernetes more modular. Custom resources can appear and disappear in a running cluster through dynamic registration, and cluster admins can update custom resources independently of the cluster itself. To create a new custom resource, we need to define a custom resource definition detailing the resource name and schema, which is usually an OpenAPI v3 schema. The Kubernetes API serves and handles the storage of your custom resource, so it exposes endpoints that we can invoke for CRUD operations on them. Together with custom resources and custom resource definitions, we find controllers. A controller tracks at least one custom resource type, and which is not necessarily a custom resource. These objects have a spec field that represents the desired state and a status field that describes the current state of the object. Now, as you can imagine, as an example, like if the controller is invoked 2 times on the same event, this whole process is called like reconciliation. So as an important characteristic of reconciliation, that is the idempotency, and reconciliation should always reconcile the state by reading all the state it needs and then write the updates to it. The state it needs, this allows like your controller to correctly respond to generic events and then adjust to the skipped or coalesced events and easily deal with application startup. So as an example, if the reconciler is invoked 2 times on the same event, it will produce the same result for each invocation. Now, we can all imagine like a lot of boilerplate code is required for a new controller. This Cube Builder is a tool that helps coping with that complexity, and by the means of Cube Builder, we can easily scaffold the code required to create our own controllers and CRDs. That being said, let's move on to the practical part. I would like to develop a very simple project that I have in my mind. We just need two custom resources, namely foo and bar, with their relative controllers. I have already shared these requirements with Francesco. Let's see if he has already worked onto them.
Okay. Yeah, I did. I already started looking into these and started looking into Cube Builder, and I've used it to scaffold our project. I understood how to use it in order to initialize the project folder, and add the code for the custom resources and the controllers. I even recorded a demo, so we can see it. The first thing I did was to initialize the project. I used the init command of Cube Builder to create an empty project. The project folder now contains a lot of files that we can use to build and test a containerized Go application that integrates with Kubernetes APIs. However, we still have nothing about foo and bar. For that, I used the create API command twice, one time for foo and one time for bar. This command created the Go files for the custom resource and for its controller. We'll now see together the foo controller code that we can find in the internal controller folder. As you can see, it contains an empty reconcile function here. You see the to-do, add your logic here. That's an empty reconcile function, and this is where we're going to put the logic of our controller. It also contains a setup functions that builds the controller and register the controllers. Here we define which are the events the controller is interested into. In this case, the controller is interested on events on foo. So anytime an event on foo occurs, the controller executes the reconciliation logic. Together with this, the Cube Builder create API command also created the Go files for our custom resources. They contain regular Go structures that can be serialized to JSON or to YAML. As you can see, there is a foo spec structure for the desired state and a foo status for the current state. What's still missing, though, are the foo and bars custom resource definitions manifests. We can create those manifests by leveraging on the make manifest rule that Cube Builder provided. The CRD manifests are generated from the Go files and stored in the config CRD folder. We can use those manifests to dynamically register our custom resources in a cluster. Do you like it?
Nice. You did a really great job. Now that we have the skeleton of our project, we can go into the details of our resources. So foo will have a foo field in its spec and a last reconciled field in the status. The spec.foo field is provided by the user, whereas the last reconciled field is set by the controller to track the last time it reconciled the resource. Bar will have a status field named foo. So if a foo and bar with the same name exist, we want bar to store the value of foo's spec.foo in its status. Now, our use case is quite simple. We don't have any real interdependency or relationship between our custom resources. That being said, can we try to implement this, Francesco?
Sure, let me get into it. Okay, to me, it's quite easy. We can implement everything, all this logic in the foo controller itself. It will be very easy. The foo controller is already reacting to events on foo. So yeah, we should just implement there this logic. So we react to events on foo, we check if foo exists. If it exists, we update it. And in any case, we then try to get bar and update bar coherently. So that will be the code. I hope it's readable. That will be the code. We just get the foo on top. And if it exists, we're going to update the foo status. After that, we, in any case, go to get bar And if it exists, we update the bar status coherently with what we found about foo. So let me put this controller at work. I share my terminal. It's split in 3 different panes. On the top left is where I'm going to input the command. On the top right, you see a watch on the my sample resource, bar resource. And at the bottom, you see the controller logs. When we apply the bar resource, when we create it, we see that it pops up in the top right. And then we do not have any logs, but when we create the foo, we see that some logs are here, the bar is reconciled, so we have the status set, and also the foo is reconciled, we have the status dot last reconciled set. So this is working great. What do you think?
Okay, but this scenario is so easy that even the wrong design just works. But if we think more about the design we have implemented, we can feel that there may be some drawbacks with this approach that we can call single controller multiple resources. Investigating a bit more, we can see that it's not scalable. If a single controller handles multiple CRs, it could become a bottleneck, reducing the overall efficiency and responsiveness of the system. Now, if an error occurs on one CR, it could potentially impact all the CRs managed by the single controller. Hence, there will be no error isolation. It could lead to race conditions and require complex synchronizations, especially if the CRs are interdependent. Each controller should ideally have only one job to adhere to, that is the single responsibility principle. This approach simplifies development and debugging and makes the system more robust, which is clearly not the case over here. And finally, a single controller managing multiple CRs can increase the complexity of the code, making it harder to understand, maintain, and debug. This higher complexity is not easy to spot now, as our use case is very easy. It will be more evident when requirements start to pile up. Speaking of which, we have a new requirement indeed, and I guess this will identify some problems and help us through. Our requirements changed a bit over time, and now we need to have another flag in bar's status that's a Boolean field named ready that we have added over there. So we are already provided with the logic to calculate the readiness as we saw before. So we will not go into the details over there. And fortunately, there are no changes required on the foo's side. It is as it is. Now, that seems the right work for the bar controller. That's what I feel. And in the bar controller, we need to check that if a bar exists, and in that case, it should calculate the readiness via the provided util, and then go ahead and update it. Now, this design won't require any change in the foo controller. We got a new requirement, and we are going to add that into the bar controller. As I already said, there is not much to say on the code of the foo's controller, and we can see that it's not impacted at all. What we see earlier, it's the same thing. Now the changes to the bar controller are quite easy, and as we said before, we just need to fetch the bar resource, calculate its readiness value, and store it in the status. When we put the controller to work, we can see that bar and foo resources are created correctly, and their status is eventually reconciled too. But the reconciliation process logs an error. When we look closely at the error is due to the concurrent update on bar, and indeed, both controllers are updating bar at the same time, and one of them is receiving an error because the resource it's trying to update is already out of date. This is also evident from the workflow which we drew earlier, as both the controllers are trying to update the same resource. So, as we forewarned while speaking of the drawbacks of the previous single controller multiple resources scenario, When we increase the complexity of the logic we have to implement, we can see an error. And let's take a look at some considerations on this design, which we have multiple controllers updating a single resource. We had a race condition while updating bar. Trying to add a condition to the CR, we encountered the error. The object has been modified. Please apply your changes to the latest version and try again. This kind of error can trigger a repetitive reconciliation process. When multiple controller watches and reconciles the same kind, redundant operations may occur, leading to unnecessary resource usage, and that also means there will be performance issues. Now, if two or more controllers are updating, let's say, the same status condition, it may be very hard to troubleshoot and track which controller made the change we are seeing in the resource. The introduced higher complexity of the code makes it more challenging to understand or troubleshoot all the problems. Now, think about a worst case scenario. When controllers have different interpretations of the CR's state, they may constantly overwrite each other's changes. This conflict can create a loop with controllers endlessly disputing the CR's state. We definitely do not want to end up in this scenario. Francesco, do you have a way out of this for us?
Yeah, let me get at this. We definitely need to refactor the logic then. It is now evident to me that we need to move the bar-related logic to the bar controller. So we need to remove that from the foo controller. This will indeed have an impact on the foo controller. As you can see, it's now very slim. It's just reacting to events on foo, and if a foo exists, it will update foo. That's the only thing that it should do. But the bar controller is now way more complex. We need to map events on foo to events on map. On bar, sorry. And there we need to check if bar exists. If it exists, if it doesn't exist, that's easy. We have nothing to do. We're fine. But if it exists, we now need to get foo and update the bar status with respect to what we saw on foo. So if it exists, we're going to update the status with the data from the foo. If it doesn't exist, we're going to remove the data from bar status. Then we need to calculate the readiness for bar and update the resource. So a quick glance at the foo reconciler. The foo reconciler is now way smaller. It's only care about foo, and it will just get the foo, and if it exists, we'll set the last reconcile field in the status and return. However, the bar reconciler, as we said, is way more complex. It's checking if bar exists, and if it exists, it will go and get foo, and it will update the status of bar coherently. After that, it will calculate the readiness, update the status of bar, and update it. Finally, we need to map the events on foo to events on bar and register those as a trigger for the bar controller. We can easily do this by registering our watches and using a mapping functions that's mapping the events on foo to events on bar. That's quite easy in our case because we just need to get the name and space of the resources. That's the way we are matching foos and bars. So with these changes, I now expect the controller just to run properly without any error. As you can see, we created the resource that's been already reconciled from the bar controller. We have the readiness set. And when we create the foo, we also see the foo and we in the bar status, and we see the foo status set correctly. So that seems to work to me. We don't see any error. Great, Feny. Your help was important.
Thank you. It's way better now. So a single resource controller design is considered to be the good practice, and we can overcome the drawbacks we encountered in the previous controller designs. Indeed, we have a lot of benefits being mindful in implementing the single resource controller design. When we follow this design, we adhere to the encapsulation, the single responsibility principle, and the cohesion concepts. That means that controllers will be independent of each other, leading to a decoupled system, and each controller will be responsible to one and only one resource. This design increases the ease of maintaining, reusing, and extending the controllers. It will scale a lot better. If each controller is managing just a single kind, it's hard for any one of them to become a bottleneck and reduce the overall efficiency and responsiveness of the whole system. It will have error isolation because all the errors for a single resource will impact only a single controller. This avoids a problem on a resource to affect other resources and make the system easier to debug and maintain. This also means that the system will be a lot more simpler, more robust, and more reliable. So to conclude, we should implement the single controller, single resource design whenever possible, as it will bring us a lot of benefits. This ends our talk. Thank you for your attention. And if you have any questions, please do ask, or you can reach out later.
Thanks, guys. Yeah. Do you want to come?
It's on.
Does it matter if the resource is a cluster?
So please bring it closer to the mouth.
Yeah. Am I audible?
Yes.
So does it matter if the resource is like a cluster, like more than one thing? Like it has its own logic of leader elections and all that?
I'm not sure I got the question.
So right
Do you get the
now,
question?
the design is that you have a single controller controlling
Yes.
one resource.
Yes.
My question is that does it matter if that resource is one thing or like a cluster? Like an example would be a Kafka cluster, or
It has to be one thing. He means that if
or is it like an abstract thing? Because Kafka is considered as one thing, but if you look into it further, it's more than one kind of pod.
he
Yeah,
means,
do you want to answer that?
No, he means that if can we consider a cluster as one resource and it has to be a single entity, or it can be considered as a whole resource, like
A cluster?
a cluster or a group of clusters or something of that sort. It's not that way, right? It's just one entity. Any single.
So basically, the idea is that when you have a custom, when you are extending the cluster by adding another custom resource, so what you want to add your own logic, like for example, you can imagine I don't know. In this case, is a foo, for example. You add in another concept to the cluster. You will need probably some reconciliation, some logic that's going to take care of the life cycle. So in a cluster, yeah.
So just to reiterate my question again, so we understand that the resource being a cluster is self-managed. Like the logic to control these different pods, it's already existing within the application logic. But when we export it as a operator or a custom resource, do we still look at it having one controller handling all the brokers or all the servers? Or do we need to have some other logic, like saying that each broker may have a different kind of exactly. So is the resource pointing to one thing, or is it like, does it matter if it's more than one? The application logic is there.
That's another more complex scenario, by the way, because you're here talking about having a custom resource that's managing them, that's basically under the hood, translating to different other resources like pods, etc. Like, for example, in an operator scenario in which you deploy your own Postgres database, and then this will maintain the pods, etc. and deployment.
So
that's a little bit more complex.
Does it still apply over there?
That will still apply over there, but you will have to take into consideration that still you need to manage the status of those resources through one controller.
The application logic I understand.
But in the new one also, like if you are trying to change something in their status, it has to be maintained by only one controller.
Right. Okay.
So it's not like you cannot do that. You can, but then there are drawbacks to that. So
Oh, so sorry.
Yeah, no
You were
problem.
saying, that case is also a little bit more complex because then you have some logic already for the pods, etc. That's already provided by Kubernetes.
Yes.
You know, so there you need to be very careful because you have also a relationship between this your custom resource and a dependency, a secondary resource in that case. So you need to be wise there to do not write logic that's going to impact the other logic that's still existing. But in that case, your controller is driving the spec, not the
Right.
status. You know, so you should
Exactly.
not probably cope with the status of the pod, but you should cope with the spec of the pod or the deployment from
Okay.
your own controller.
So
But
it'll be more of kind of reference rather than it'll be immutable kind of resources, and
Yeah.
you'll be watching them and
You
reacting
can
basically.
watch them, but you can watch them, but you cannot do the changes to the. I mean, you shouldn't do the changes to the status.
Okay, you should leave the application logic within the
Yes,
application.
single controller. So watching is fine. That I mean, that anyways you will have to do because as you
Okay.
increase the complexity, you need to watch many different resources. So watching is fine, but changing its status should be from one controller.
Okay, got it. Thank you.
thank you. Sorry, I didn't got the
Yeah,
question.
yeah, please.
I don't
Yeah,
know.
yeah.
Okay. Please.
So great talk, and I have two questions. So first
Yeah.
question is, you described three scenarios, right? The first one was you had a single controller which was managing two
Two
resources.
resources. Yes.
Then you tried to. Then in the second scenario, you had overlapping.
I had one controller
Yeah.
which was managing
Both, and the other was managing one. So
Then there were
that
two
caused the race
controllers where,
condition.
which was managing one
Right.
resource.
And in the third scenario, it was a single resource.
One to one,
thing,
yes.
right. So, in the slides, I'm not sure if I followed right, but it seems like you kind of tied single controller, multiple resource to be in the same kind of place as, say, multiple controller, single resource. Am I right? Does that make sense?
I'm not sure if I understand that.
So what I'm trying to say is the first and second scenarios are different, right? But,
Yeah, they are.
But in the slides, was it also mentioned like that? Because I kind of understood it like you gave the same kind of disadvantages for both of them.
They are mostly similar, but in the first one, it was like when you do it, like you are not seeing something very evidently or very easily. And
Right.
it's like maximum you can see that it might be going very smoothly, but you don't spot that out. When you scale up, then you find it that okay, it's not working fine. But mostly the drawbacks are almost similar, but we encountered an error in the second scenario. We didn't encounter any error in the first scenario.
Yeah.
Because it was like
The race
just
condition
us.
is impossible. In the first
Yeah,
scenario.
I mean,
Race condition.
Yeah.
so there was no race conditions. It was there in the second one,
True.
and they are almost tied up that way. But I mean, there is a difference to it. Like when you are managing, when you are trying to manage the same resource from like two controllers are trying to manage the same resource. Race condition is the first one, and it will lead to the other drawbacks which are tied to it. So it will not scale. All the things are already tied up.
Right.
So it's almost similar, but in a second scenario. So that is something we took like two examples which were like very common when we
Yeah.
try to implement that. We
Yeah.
intend almost like not to go that way, but our mindset is okay, we can do this.
Right.
So that's the common scenarios which we took.
Okay.
So for the first scenario, I also did not get like what kind of challenge if you have a real life example where scale can cause an issue.
So that's what we did. In real life, if I mean, it just worked. But when we tried to scale, when the requirement piled up, you are never going to design a system which is like just going to be there as it is till the last. You will always have requirements to be added to that controller, or you will always need to watch some more resources, or you will always add up, try to scale that better. So that's what we did in the second one, that if you have not followed that design from the start itself, what happens? When you try to scale, that's what we did in the second scenario. When we tried to scale, when we tried to add the requirement to that, we encountered the error. That would have been like you go through that, then you find out that okay, now we are not able to scale up. Then you have to just redo everything.
Just one thing. In a real life scenario, the first scenario can be really bad when you, for example, have the foo in this case, the foo resource that has a very complex or long reconciliation, and that may fail independently of others' resources, and you are stuck in your reconciliation with bar that's never reconciled because the full logic produces an error. So you don't have really, you never reconcile bar. In this case, we try to simplify, to oversimplify, to make the communication a little bit better, so it was not easy to emulate. But that in a real life scenario, that's what can be like, that can happen, and that happens a lot. Another thing is the error isolation. So you're a little bit, you go to the logs, try to understand what's happening, and you find nothing in the bar reconciler, and you don't understand why bar is not reconciled or what's happening, etc. And then you need to go and filter full controller. That's a little bit counterintuitive, So that kind of problems are more evident in the first scenario.
One question, excuse me, one question. So the doubt is like, it greatly simplifies the maintainability of the controller. But if there's an interdependency, then maybe you already explained, but just to repeat. Maintainability of the controllers will simplify, but if at all there's an interdependency of the CR itself, what is your recommendation where it's supposed to handle it? Outside the controller, the application? If there is an interdependency between these resources itself. I mean, I have a dependency between who and what.
Yeah, okay. In that case, it's just a requirement. You're going to have this interdependency, this relation between the two resources by requirement. So I'm not sure I got the question.
Maybe.
Oh, yeah.
Okay, so that converts to like, a more complex scenario. That will be like the primary and the secondary resource. So like that's how it might go to the dependency on it. Even though if it has a dependency on each other, there will always be something which is a primary resource for you, like which is the main resource which you have to maintain. You can watch other resources, yes. That's not like you cannot watch like two resources from one controller. Yeah, you can watch it. So the main thing relies on, you can watch as many resources you want, but make sure that you are only updating the status of one.
The reconciliation is about what
Yes. Reconciliation is on is one. Yes. Sorry?
I just have one
Yeah,
question left.
please. We'll just finish that.
So
Yeah.
I wanted to know, what are the pitfalls of the solution that you've mentioned, having one controller per resource? One thing I can think of is for the teams that are managing the platforms,
So
there's that much more overhead because you have to keep track of the newer versions, and then you have to update all of them. You have to kind of keep track of multiple controllers as opposed to just keeping track of one in the first case. So
I would say like it's a trade-off for you. Like it's not like you have to keep track of all the controllers. It's always easy that one controller is managing one resource, so you know that if an error comes into one resource, you know where to look. But if it is only single controller, I know like you are talking in the terms of maintainability of those controllers. But what would you rather have? Like a system where you cannot, debug to a point like it takes you maybe 2 days to just reach to the error in the controller itself, or maybe just keep a track of. It's not like you cannot do it. There are scenarios where you can do it. It's just the recommended practice which makes your life easier.
thanks.
Yeah.
I don't know. Let's do a queue. Let's start from
Okay. So I have 3 questions. First would
Okay.
be when you explained an example where you first were getting foo, then updating it, and then getting bar, and then updating it. My question would be, does that whole function have to be atomic at some point of time?
The question is?
Has that piece of code has to be atomic or not?
The creation?
The first get, then update, then get, then update. This has to be atomic.
Atomic?
It should be in sequence.
it should be idempotent.
Yes.
It should be idempotent, but it shouldn't be.
Is idempotency, right?
Yes.
So that's what is asked.
So if it repeats, then also the state should.
No, I'm just saying if, let's say get, delete. Even if the last delete fails, would we recreate this delete that we had done? Like rollback. Do we have to roll back, or that's fine?
That depends on the controller logic, right?
So our logic should be idempotent.
Yeah,
Yeah, the logic usually should be idempotent.
Okay.
That means
reconciliation. Yeah.
that means to simplify, to oversimplify, you need to get all, when you start the reconciliation, you need to get all the information that you need for doing the reconciliation, and then update them. And two executions of the same, on the same event with the same state, initial state, should lead to the same result. So that's a little definition of
So the second question would be, would the controller logic be responsible for handling the idempotency?
The controller logic should be idempotent. So you should implement this. Like a common example is the between the difference, with two functions is actually like you have an API that you can invoke that will increment a variable, a counter. Yeah. That's not idempotent because that if you execute that 2 times, because you have a repeated event that will produce like 3 from 1. But if you have a function, an API that's setting the value, and you just give the value, and the value should be 3, if you have 2 execution of the same event, that will produce 3. And you should aim at implementing a logic in the reconciliation that works this way. So it will get every time all the information that it needs, calculate the future state, and apply the things that needs to be done.
Got it.
That's the idea.
Okay. And the last question would be, let's say I was stuck with the use case where, the first use case where you said like do something when bar changes or foo changes, and everything was done in the same controller. But let's say I don't see any change in that controller logic or dependency between foo and bar for all, let's say 6 months or 7 months. Do you still think we should go with single controller, or just do it the normal way?
That's a trade-off, you know. If you have an example, a scenario that's so easy, like the first example, you can just probably go that way. You want to adhere to the good practice, but that should just work, you know. So in that case, it depends from the needs. Actually, when you need to scale, the best thing is to start to be compliant with the good practices, and that will help you keep the reconciliation logics across multiple controllers way cleaner and very manageable and scalable. You know, that's the idea.
Sure. Thanks.
So the main drawback was just performance issues?
Performance, maintainability, complexity, all of those.
Like error resolution, you won't know like from where you got the error. You will have to go through everything again. I mean, if that is big, like you will spend like hours and hours into that, and that would be
Hi, I'm thinking a scenario where I want to modify a resource which is not owned by me through API server, like sidecar injection for deployments or pods, which is being done by Istio and many other tools. So how do you think about that? There's a controller which is triggering changes into deployment, which is a resource not owned by itself. Does it apply what you have said, or is it a controller of controller kind of scenario?
Okay, that's a quite complex question, and
you can go with the example of sandbox, like primary, secondary.
want to take it?
So, like, you can always bifurcate your resources into the resource which is primary to you and a resource which is related to that. So, you can make changes to your primary resource which you are maintaining of that controller, and you should always make changes to the status of that. You should never go and make changes to the spec. You can make the changes of spec to the secondary resource which is not maintained by you. You can make changes to the spec of that resource, but any one resource which you are trying to maintain as a first resource or the primary resource, that is something should only be handled or managed by the one controller.
Okay, so status should be owned by one controller, but spec can be modified by multiple.
Yes. So you should always make sure that spec and status should not be changed from one controller. That is always by different controllers.
Understood.
You can watch as many resources as you want from one controller. That's not an issue.
That is the control in place, basically.
Yes, you can watch as many resources. That's not an issue. The main concern is you should never change or update the status from one controller to different resources, or two controllers on one same resource. Or
That will cause the confusion.
yes.
But one controller can update spec of multiple resources.
In that case, we're going to have a primary-secondary relationship between the two resources. You know, so like for example, we were discussing before, or like the deployment example. You know, deployment is basically changing the spec of the replica set and replica set on the pod, etc. And you are in a situation like this that's a little bit different and a little bit more complex than this, because you have this relationship that's primary, secondary. In that case, I'd personally suggest to just update the spec of the resource that you are driving. That's yet you have the CR, and your controller should just update the spec of the other resource with respect to what you want, what your controller wants. So you change the desired state, so basically the spec, and have the controller of the other thing that's doing the changes, reconciling to get to move to the current state.
The changes made by this controller.
But you don't. Oh, sorry.
Whatever behavior is. I guess for this use case, we can also use webhooks, right? So that it can actually watch for events where we want to add a sidecar. So for such events, I guess mutating webhook will be.
See that you will.
For both, right?
Mutating addition control.
Yes, you can. I mean, that's what the primary focus for you should be, that when you write controllers, you can watch resources from that same controller, different 5-6 resources you want to watch. You will have to do that. I mean, anyways, you can't have any simple systems this way. So watching is fine, but changing the status of one resource should be from that controller, your primary resource. Now, if you have something dependent on that resource, so that will be a secondary resource. So you can change the status from other, but you can change the spec from this one. So you can do that, but you just have to make sure just update the status from one.
It's kind of a deadlock to avoid all any deadlock.
Yes.
Very simple.
Interdependence.
Yeah. So hi, my question is just a little side of this topic. I have been using Argo CD a lot, and I have migrated over 600 microservices within same cluster. So we were facing one issue where Argo CD controller, we are only able to scale it vertically for one cluster, right? We have not enabled sharding because all of our microservices remain in the same cluster. So my question is there any way we can develop controllers, something like having the strategy of queuing systems like partitioning, so that distributed controller, so that we can horizontally scale one controller which is managing one CRD? Is any strategy like that possible? Because there is always a limitation to vertical scaling, right? And when it comes to 600 microservices, now let's say it is working and it is just lagging with few minutes, right? Now let's say I double the resources it is managing. Now what if my microservices number becomes 1200? Then single controller is still working, but I'll be facing a larger lags. So what to do in those scenarios?
That's a little bit complex as a scenario. You can actually, usually the controllers works with the leader election, so you cannot have more than one that's running at the same time in the same cluster. So even if you scale them, you will have only one that's serving that's reacting to events and applying the logic, and when it dies, and one of the other replicas will come in. So what you can do on the same controller is to change some parameters that we have there to enabling multiple threads to work at the same time, so you will reconcile more events. After that, it's a little bit concerning as a scenario. You need to that's a very complex scenario in which you have a lot of things to do.
Yeah.
So one thing to try would be to manage the concurrency in a different way. But yeah, that will be a little bit of a pain. So you can change. You can try removing the leader election mechanism and having more controllers that are executing, but then you need to move the synchronization between those to another system, and that may be a pain too. So yeah, a need of investigation on that side is something that you could do, but it's not an easy task actually.
There's no non-use case for the distributed way.
The distributed.
Like if we have multiple replicas of the same controller working together, doing the same
You could
thing.
watch on a single namespace. Would that work? Multiple operators, each one on the same one name.
It depends, because usually it depends from the scope of the controller actually of the resources. If it's for example a cluster scope resource, you cannot do this. And yeah, if it's a namespace scoped resource, you may do that. You need to probably work a bit with the leader election of the controller, but you could achieve this. You can.
But still, leader relation comes into place whenever there's a failure, right? In case of HA, right? But in case of his question, he's asking like, what if the load increases to the same controller? How will you scale it up, kind of? intuitively, how will you make it less congested or whatever?
In that
Relax.
case,
Maybe improve some resources, whatever, like what you mentioned, right? Change some configuration parameters of the same controller. You were mentioning
yes,
before, right?
you can use this, but you will still face problems with the resource limit at some point, because you should increase those resource limits until a point in which, as he was saying, basically it's too much for each node of the cluster. It's actually a bit difficult to reach that point, to be honest. So I've never seen a scenario like this in which you have a controller that needs to have so many resources that's overseeing basically the power that you have in your cluster. So that's definitely something that needs to have.
Yes, so what I was thinking, something like this, and I wanted to validate this. What if we build a controller which just watches the resource, just watch, and pushes the message into Kafka or any queuing system, and from that we have another controller-like structure which is replicated now because it is consuming from the messaging system, and then it sends back to some events to this controller, and this controller now updates that to the CRD, something like that.
That may work. That's actually a very complex scenario. A lot of tries should be done there. I really don't have an answer for this. Okay. But that's a good idea. That's one of the path probably. You may have some problems with the ETC.
But right now...
But there is another speech now, right?
Yeah.
He has one question.
You have the speech now, guys?
Thank you.
Will break the
Yes?
motive of whole
Okay, so we can go.
Yes, please.
So I am like maintaining controller at my company, like an operator at my company. I wanted to know, like this is one of the best practices, right? Single controller, we follow this. But do you recommend any resource like a book or a thing which I can follow to get to know all the best practices? I haven't found much.
If you go to the KubeBuilder page, it has a section. I can show you that.
Yeah, we have the link over here.
Oh, we're already there. But yeah, guys, I'm not good with Mac. No.
Okay, you have it.
No problem. We're already there.
So,
I don't see. Okay. If you go to the KubeBuilder, there is a section that's good practices. Yeah, you see here, 5.3. And you will find these good practices that we showed today and a couple more, like hidden potency and others. This is the design in which a single controller is responsible for managing multiple CRDs, you know? And those are the problems that we listed today. And there are also other here. Multiple controllers, same CRD, same CR. Status conditions also very important here. And there is the idempotency and the API conventions, the Kubernetes API conventions. So those are the main good practices that KubeBuilder is sharing and suggesting, actually. Yeah, thank you.
thank you.
Any other question? No, please.
You all tried all the approaches that you discussed, right? So, when did you encounter a problem that forced you to think about multiple controllers in single resource? And another question is that, do you see any problem where this situation might be, say, favorable compared to others?
Sorry, second question?
Multiple controllers for a single resource. What made you think in that direction? Any problem that you encountered while working on controls?
Yeah, we saw that in multiple controllers because when you are actually working then on a product that is way more complex than these kind of examples, or sometimes you have some constraints, like for example you have a bug in production and you need to fix that, and that's the easiest patch that you can produce. You may introduce some changes that are not that's not adhering to this one, to this good practice. So that's actually happens a lot of times, and in Italy at least we used to say there is there is nothing that's more definitive that's a temporary patch. So actually, when you introduce a little change, that will be temporary, will change that. You usually end up having this like for 3 years. I don't know why. So that happens, to be honest. We saw a lot of examples in which we have multiple controllers, like really a full controller that's updating another resource because it needs to do some changes, and then you basically just lose the flow of the logic of that they should be applied to that resource. And when the controller starts to be multiple, like hundreds of line of codes, or a lot of basically invocation of new functions, etc., this becomes a real nightmare to understand what's happening. So we faced that on multiple projects, to be honest.
So it's not like you cannot do. You can do it. Everything you can do. It's just a recommendation.
Trade-off
so
would be
that
there for
you
everything.
don't face those things in future. Like in future, if you face that, you are anyways going to come back and do it. So you don't have to redo it. That's the reason
Sometimes that's not even a problem. For example, you saw the second one. It logged an error, so we have an error, but eventually both the resources were reconciled. So, it took one cycle more, but it was reconciled. It starts to get to be more problematic when more complexity is added, or when the deadlock example is very bad, live lock, I think, in which basically two controllers are changing the status reconciling the resource, the same resource, but they implement a different logic, so they will trigger
endlessly.
The other end will say you just stuck there, You can see that in a lot of cases, like for example with Argo CD, in which you define a state for a resource, and then there is an operator that's changing the state, so Argo CD is reconciling again, the operator is changing, etc., and you have this loop. In that case, it's really evident and easy to generate, to be honest. When you write controllers for these kind of things, it's actually something that if you take care from the beginning when you are designing the reconciliation logic, that will help a lot. That will really help a lot.
Thanks.
Welcome.
So in terms of OpenShift parlance, this thing that you spoke about, primary and secondary, does it apply to OpenShift logging and Loki, where Loki is the managed resource? I hope you know what I'm talking about.
I'm not working directly on that part in Red Hat, but the primary and secondary is actually a scheme that's very that mandatory to use when you have a resource that's managing another resource. So, probably yes, you will find there this kind of
Because
relationship.
we don't create Loki separately. We just create OpenShift logging. There are two operators. One is OpenShift logging. The other one is Loki.
Okay.
And then OpenShift logging CR basically manages the Loki CR.
Okay. Yeah.
I don't have to separately.
Yes, that's a primary
Secondary, right?
Yeah, you basically, your controller that's reconciling your resource is applying the changes to the spec of another resource for obtaining the result that you want.
But in this case, I have noticed that if I don't have Loki installed, that CR just errors out. If the Loki operator itself is not present on the cluster, and I have created an instance, a CRD of CR for OpenShift logging instance, it errors out because it cannot find the definition of the dependent resource.
Yeah, that's actually happening at runtime, because you at runtime are basically creating a scheme in which you register all the CRD that you want to use, and then it goes to the Kubernetes API server with a REST request on a resource, but the API server says, okay, I don't know that because you never installed that, and you got a 400, I think, or 404 probably, and that's the error that you see. Because Loki is not there, because that CRD is not installed in the API server, so you don't have the API server cannot understand what you're talking about. It doesn't find the resource. You need to install that, and by the way, this won't be enough, because if you just install the CRD, the result that you will have is that the CR will be created but never reconciled, because it's the Loki operator that will reconcile the resource. At that point, By the way, if you install at least the CRD, you will see that there is no error there, but probably the status of the login CR that you're creating will never be updated or will still remain in a intermediate state saying, hey, I'm waiting for that because I'm looking at events on that. I'm waiting for that to be applied correctly, reconciled, and whatever. And you still be basically blocked there, waiting for the other until you have an operator that reconciles that. So that's an example of primary-secondary relationship.
Okay. By the way, I'm a Redder too.
Oh, nice.
Yeah. That's why I know about OpenShift.
Oh, nice. Thank you. I didn't read the thing. Well, okay.
So I came across this problem recently. So our CRD grows in size, and whenever it reaches 1 MB limit, right, we start to hit issues with Helm, issues with any other deployer because of the config map limit.
Yes, because that's a limit from etcd, the database that's used by Kubernetes. That has very strict limits. Like, for example, the maximum size that it can have is like 8 gigabytes, nothing more than that. And also, they do not recommend to run with 8 gigabytes. They prefer to have lower limits in the full size. And each element should be maximum 1.5 mega. Config maps, secrets, and CRDs. So when your CRD starts to grow bigger, and the problem there a lot of time is with the managed fields, because when you create the thing, maybe it's like 1 mega and 400, and then the Kubernetes will apply the managed field annotation, and it will become like 2 mega and something. And when you try to update that again, you will have some problems. So yeah, that's something that happens all the time, but that's a limit on etcd, as you were saying.
Yeah.
In that case, the only thing that you can do right now is to trim the size of the CRD, try to break it down in multiple pieces, or I don't know. By the way, personally, I'd never suggest to have a CRD that big. Probably something's wrong. Like, I don't know, an example I can think of is the key clock. Key clock can be huge. Don't know if you have. Probably that's as a reason that's good as it is, but to me, every time I have to manage that, it's very big. I got lost a lot of time. So my personal preference is to have smaller CRDs, but then you need to be mindful to do not pollute with like 20, 30 CRDs. So it's engineering, it's trade-offs. So you need to be mindful about trade-off when you design all those things.